Well, hi, good morning. Thank you for keeping me company here. It's the Ides of February. It's February 15th, and the expectation here is a big snowstorm is coming. It's gotten cold again. My gosh, winter has returned here. That's what's happened. And I certainly have no grounds to complain about anything because other parts of Canada and other parts of the world are experiencing, of course, much worse weather. This has really been a great, easy winter here so far. Maybe things will change today. So, what am I doing now on this radio? Now it's time to check through and readjust the alignment elements, or alignment elements, I guess I can call it that, in the radio. You can see all these holes. Behind all these holes are little trimmers to be adjusted. There's no trimmers here on the capacitor. If you notice, the capacitor has both sections are exactly the same. So in many radios you'll find one section is smaller than the other. The smaller section is driving the local oscillator. Hope I got that right. One is the local oscillator, one is the antenna tuning side of it. We don't know which one's which on this radio right now, just looking at it. But what this means, when these are the same size, it means there's a compensating or compensatory, I better not even use that word. There's a capacitor connected in series with this, or maybe it's this one, connected in series. And so to tune the local oscillator in a radio like this, there are usually two trimmer capacitors, one in parallel and one in series with the arrangement. Well, I don't know, is that true? I never really know if what I'm saying is true. Okay, right, so the alignment, and there's also two alignment adjustments up in these cans here. If you look inside, you'll see there's a screw in there, screw heads going to little trimmers, little trimmers. I had one laying here. I could just flash it at you, but I can't find it right now. So those are all the adjustments that have to be made. These, oh, looks like there's even more here to make. That's quite a few adjustments. This has got many bands. It's got 5 bands. To be 5 sets of adjustments. These only get adjusted once. Actually, everything only gets adjusted once, but you're changing band and moving across as you go. These are operating on all bands at all times. And what this really is, this is an extremely clever trick that some engineer figured out, I don't know, very late 1920s, where instead of having a radio that has 4 of these in a row, basically, each one its own radio, each one tuning exactly the same thing. So the signal's going through them, getting stronger. There's an amplifier tube involved in each stage. But every stage has to be tuned, and they all have to be tuned exactly the same, or if any of them, get out of alignment, you're not going to hear anything, or it's going to get weak. 4 or 5 of these things in a row, that's pretty challenging. So somebody said, well, rather than having the whole radio tuning, can we fix the tuning of part of the radio and then somehow trick the signal into that particular frequency so it goes through the fixed tuned part of the radio? Then we can create a radio with much better performance, because we can hone it. It only has to operate at one frequency, and that's what this is. So the signal comes in from the antenna, doesn't get very far into the radio before it meets up with another signal that get mixed together, and out comes 4 signals out of this mixing process. And this part of the radio, this is a terrible explanation, this part of the radio is tuned to one of those 4 frequencies. That's really kind of a misleading explanation, but the basic idea is the signal the converted signal can pass through this part of the radio. Nothing has to be tuned here to keep up with it as you tune across the band, because the thing you're listening to is being converted to the frequency that these things tune. And what is that frequency? 455 kilohertz. Very, very common. 455, 460, and in that range. Some very old radios are very much lower, 120, stuff like that, 160. But normally it's 455 kilohertz. Probably half the radios in the world have that kind of IF frequency. IF, intermediate frequency, intermediate stage. Intermediate between the tuned antenna and the speaker. It's intermediate. How about that? You know, I shouldn't really explain things. I should just do things. I mean, there's, I'm sure, far better explanation. Well, that was a terrible explanation I just gave. That was a bad one, Jim. Okay, so what are we going to do? So before we start tuning up these things down here, we should make sure the IF, the intermediate frequency stages, are tuned correctly. Radio's operating, so nothing can be too far out. So that's the first thing we're going to do, is we're going to check and correct the tuning of these two tuned transformers in here. Man, I'm talking a lot. I gotta get busy. And you know what it is? I think it's because I haven't even poured the coffee in my cup yet. I'm gonna go do that. Okay, we're looking at the service manual and the dial plate, obviously. And you see there's a ruler down here, and what they're trying to do is help you deal with the problem that this dial plate stays in the cabinet and the radio's on my bench with no dial plate, so I don't see any of these numbers. Where am I tuning things? The first issue is, where is the pointer starting on the string? And so I believe that's what they're showing here. These, they're calling index marks. The radio out of the cabinet, dial calibration points should be located by making pencil marks on the backplate below the pointer, with the radio out of the cabinet. Figure 1 shows the measurements for these points with respect to the extreme edge of the backplate. Extreme edge, that's important. At the low frequency end, that's also important, but that's a little obvious, isn't it? Yeah, that's a little obvious down here. Although figure 1 shows the dial scale for the model blah blah, and the same for the other model. Okay. Dial backplate calibration measurements. So they don't actually say, and the pointer should be lined up with the index marks when the capacitor is closed. They don't actually say that, but it sure looks that way, doesn't it? I mean, it has to be this way. Why else do they put these dots here and call them index marks, and they all line up perfectly straight? Why didn't they put just one? Well, because they want it to look uniform, so they put them all here. So a person wouldn't ask themselves, what's this one dot here? So it looks like I measure to edge of dial backplate. So it should be measure from edge of dial backplate is what this should say. And oh look, so he's put a line here. See that little extension line? There isn't one here. You know, at a glance it looks like this is lining up here, but it's actually not. A little bit of bad drafting here, because it's just, you know, drafting is about communicating, and this is just a wee bit misleading. So dial backplate, we measure in 2 3/8 inches, and then that's where the pointer should be when the capacitor is closed. 2 3/8 inches. I have to get my inch ruler out here. Okay, I have my ruler out. We're using a green ruler. 2 3/8. 2 3/8. So that would be 2/8, 3/8 right there. From the extreme edge, there's more than one edge on these backplates. So the extreme edge, this would be the extreme edge. Let's close this guy. Okay. So measuring 2 3/8 should be way over here. Should be 2 1/4, 2 3/8 should be right there. Right there. How can I mark this easily? Just get a little tidbit of tape here. Two and threes. Look at this. I can't put it up here. I was going to do this kind of thing. That's not even a good idea because this will run into it. Just use the ruler. Okay, we're going to move over that way. Whoa, way too far. 2 3/8. Bottom corner. Just grabbing the string here. A little bend on the pointer. Pointer straight up and down. Huh, looks pretty good. Must just be me and my glasses. Gotta go a little further. This is still closed. Just a little bit further. There we are, bottom corner. That's about as close as I'm going to get. 2 3/8. There we are. What happens on this end now? Ooh. Oh, you're going to stay on, string. Don't come off now. Be a good guy. Here we are. So, and over here on this side, it's roughly the same. So it's oh good. That's good. Centered. Now I'm going to have to make more measurements of those other things. I'm going to do that off camera, and then we'll get going on the actual. I don't even need to do any of this just yet. No, I don't need to do any of this. I'm doing the IF, which doesn't involve the pointer at all. Okay, let's carry on with that. So over here, quietly, my signal generator has been waiting for its turn. Things for we'll put it just below 455. We're gonna jam the signal into the radio's antenna, hoping some of it will make it all the way through. A radio that's terribly out of alignment, maybe you couldn't do this. But this radio is not terribly out of alignment. It works. So this is more a fine adjustment. Okay, now we need some alignment tools here. There's a good one. So we're going to line these 4 screws on the top here. Let's go up a bit. And I guess I have to have the radio operating to do this. So now would be a good time to have a little coffee break, and then I'll carry on. Okay, let's start up the radio, then I'll explain what's going on over here. First volume down, here we go. Okay. Just waiting for some sound. So this meter is going to measure the voltage that's reaching the speaker. So we're going to have the speaker operating the whole time. So I'm going to set that up. Put this on AC. Put this down to like 3 volts. And we are hearing absolutely nothing. How come? How come we're hearing nothing? Okay, maybe I should your band switches on broadcast. Gives us the strongest sound. Nothing whatsoever. Okay, so probably a problem here. This is just the speaker connection to my speaker. It looks perfectly fine. What has happened here? The tube's definitely heated up. Oh, confusion on the volume control. Who's who? That's what that is. Whoop. Yeah. Okay. Bit of excitement there. See if we can get this meter to go up. You probably can't see it moving from there. How about this? It got a 0.3 volts on an AC meter. Wow. Of course, this is a transistorized, amplified meter. It's not your normal meter. So there we are. We see some voltage there. Now, we're going to tune this to 455, and hopefully we'll hear something come out. Should hear a 400 hertz tone. Wow, that's pretty good. So we're in 455. I'm going to adjust the trimmer, so we're going to try and make this go up. That's the idea. Very precise one there. This is tuned very, very good. Very, very well so far. Out just a wee bit. Wow. So if it's the case that this has never been tuned since day one, since it came out of the factory, wow. That's hard to believe. These were just right on the money. Okay, that's it for that. There's no more I can do about the IF. It's tuned beautifully, which is another reason why this radio's been working really well all the way along. Now we're going to look at these trimmers and the ones on the back. Let's go to the instructions and just read them over. Read them over. Here we are. Alignment procedure. 2 models. Caution. Before turning on the radio. Oh, it's a little too late for that. Make certain the voltage changeover switch. No problem. Dial pointer. Here we are. With tuning gang fully meshed, set the pointer to coincide with the index mark at the low frequency end of the dial below 55. And I did that by using measurements. That's when we put the chassis back in the cabinet, we're going to find out it didn't work out 100%. This is usually what happens. Output meter connect to the speaker voice coil. That's what I've done. Signal generator connect ground lead chassis. Did that. Connect output lead as indicated in the chart. Didn't do that. Radio controls volume to maximum. No, I'm not doing that just yet. Output level. During alignment, keep it as low as possible. Adjust signal generator output to maintain output meter indication below 1.5 volts. Okay, that's good. And then here's the actual instructions here and all the pointing. So I just did these. Let's see, they're first on the list. And actually it says connect to the antenna. In some cases they would say connect to a grid on a tube, but that's a big hassle. Dial setting 540. Wasn't quite there. That doesn't matter. Very good. Now we go here. Let me just zoom in a bit. Step number 2. Through a 400 ohm resistor to the aerial lead. So we're feeding in the signal through a 400 ohm resistor. And we go up to 21 megahertz.
on shortwave 4, which is the 5th band. We set the dial to 21. How do we do that? Well, we measure it with the ruler. Adjust for maximum. Image should be heard when radio is tuned to 20.1. So the reason they're telling you this is because it's so easy on these radios with a low frequency IF of 455 kilohertz, but trying to tune in very, very high frequencies like 21 megahertz. The IF is a small percentage. 500 kilohertz is a small percentage of 21 megahertz. And the result is the image is very close to the tuned frequency. It's just a megahertz out, 900 kilohertz out. That's why they're saying you should be able to tune to 0.1 and hear it. If you don't, it's probably on the other side, and you've actually set the radio up on the image frequency, which you don't want to do. That's what this is all about. So we'll get through that after I go away and drink some coffee. We'll set this up and we'll do this one. This is fairly important. Same thing here. We're doing it at 12. Look at this. 21, we go down to find the image. This one here, 12, we go down. 9, we go down. 6, we go down. So in every case, they've arranged it so the local oscillator is above or below the target frequency. Below. It would have to be below the target frequency to put the image further below. So we know what the local oscillator should be. Back in the day when they wrote this, a person doing this work in their shop wouldn't have no way of knowing what the local oscillator frequency actually is, or virtually no way of knowing for sure. But we do today. It's very easy just using an SDR, so I'll probably do that too, just to keep an eye on the local oscillator frequency and make sure everything is adding up properly. Okay, so that's the one. Right, coffee next, then step 2. They didn't write coffee right in the list here. Okay, let me show you what's going on here. Hey, volume control. Wow. So this coil here, which is just a clip lead coiled up, I've shut it down in a place where I'm pretty sure there's going to be a lot of IF signal floating around. Just down in here, I'm trying to. I don't want my leads to short out there, so it's just down in this area near the capacitor and near the mixer tube, near the first IF. So we can look on the SDR screen now, and I'll show you something weird. Okay, so we're looking at the SDR screen, and this number up here represents where the red tuning line is. The SDR is a radio, right? And I have the sound turned off. There, I've got the sound turned off, so we're not listening to it. Here is the medium wave broadcast band, right in this, where this blue line is, and it says medium wave right there. One of these peaks is the radio's local oscillator. I will tune the radio, and this will cause it to move. Now you can see, you can hear me tuning it, and you can see the result. So right now it's right around 1500 hertz. And that's probably correct. Close anyway, I think. I mean, the radio does work. Let's tune down. Okay, so the pointer is in about the middle of the dial face right now. Hey, where to go? Exactly. Where to go? I go back up. The oscillation stops right there. That's what the SDR shows, but I've had this radio operate. So let's tune way down, see if it comes back. Now this could raise some questions about how I'm doing this. Is it because of the way I'm doing this? I've never had this happen before where an oscillator, it just disappeared. Let's go back up. There it is. Okay, and it's in the same spot on the dial face. and then we can go up. It gets stronger and stronger. Now normally the local oscillator in a test like this on my SDR shows up really strong compared to everything else. This is stronger than everything else, but it's not really standing out. It's weak. It's weak. Weaker than most. I mean, it has a lot to do with where I put the pickup coil. You can hear me slowly tuning it. Boom! See it pop in? Pop in. Now, can we hear this effect? Let me turn up the radio. Okay, so this is a signal basically shoved into the IF. We don't want that. So I'm going to get rid of this. Okay, so we don't hear that anymore. And turn it up here. And we just tune along. And does something change when this disappears? Didn't hear a thing change. Well, how could this radio have worked? I'm going to put an antenna on it and see that it doesn't work before I do any more here, because it would appear that it cannot work at the lower end of the band, yet it does. Okay, so I'm going to disconnect the signal generator. Maybe that in itself is causing a problem. Yeah, keep the volume down while you're doing that stuff. Let's just, now with this disconnected, let's look at the local oscillator again, see what happens. Now, I wouldn't expect this to make any difference, but where did the think man think? Why is there no local oscillator appearing at all now? What is going on here? Okay, I'm going to move around the pickup coil. I'm going to turn up the radio. It's very, very quiet because there's no antenna. So I'm literally putting it right on the plates, right near the plates of the oscillator capacitor, tuning capacitor. This is a little odd. What, am I doing something stupid here? We're definitely on the broadcast band. I'm going to put that antenna. I'm going to put the... Well, I have to stop because I have to go and turn on the antenna. So I'm going to stop here for a minute. We're going to play the radio normally. Just, what's happened here? Okay, so that is coming from the antenna. Our antenna connected. Let's see if we can find a station now. Oh, wait a minute. Let's get the SDR looking. So here's the SDR coil. I'm going to put it right in this area. This is where I saw it before. Okay, tuning. I'm waiting. This is the spot where the action started, if you like. Is right up in this area. So we're watching for the local oscillator to come on anytime now. Oh my gosh! What? What's happening here? So the radio's not tuning anything. If you notice, the sound doesn't change at all. That's indicative of a missing local oscillator. You know what it might be? I'm running the radio at 100 volts. Yeah, that could be it. That could easily be it. Okay, let's turn it down a bit because I have a feeling it's going to get a little louder. Okay, we're going to go on full voltage here. Watching the... I'm going to tune this first down towards where it was. It's right in this area. Local oscillator would kick in. right above my finger, somewhere up in here, I think. Okay, full voltage. There it is. Oh, did you see it pop in? Huh. This is the first time it... What was that? What the heck is that? Watching for smoke. See the local oscillator strength just change? Now, see how tall the local oscillator is? That's the way it should be. Why is it going up and down like that? Loose tube. My pickup coil is wandering around. Let's just push a few tubes around here a little bit. Let's try this one here. This is the actual detector tube. Those are the only two tubes that can really make a difference here, I think. Really, it's just the detector tube. Not sure what to make of all that. Okay, we're in business now. Finally. So it's just running it on low voltage, was it? Let's go down there. That's a French CBC. I wonder what that was. That you noticed on the SDR, everything came up for a moment and went back down. I wonder what that was. Who knows? Okay, so she's working fine. Okay, sorted that out. Now it's clearly time for some coffee. Oh, weather.
Thanks a lot, guys. This report brought to you by Clifton Blake, eastbound 401 south of Pearson in the collectors. Left lane is blocked due to a disabled vehicle. Shouldn't cause you much of a problem, neither should this one either.
Weather, come on.
Right lane also blocked for that exact same issue of a stalled vehicle. So delays right now from east of the 400. But again, if you are moving in the express before getting to this, it should be no issue for you. Westbound 401, small little volume delay here. This is from west of Bryn Lane to Kennedy in the express, but that is pretty much disappearing. Southbound 414C from south of Finch to south of Lawrence. And then if you're traveling on the eastbound Governor, you should keep it.
Didn't he say weather? I thought he said he was going to do weather.
From Parkside to Strawn, and then again from east of Spadina to the Jarvis ramp. Time is ticking. The deadline for your RRSP is February 29th. Make your money work harder with Clifton Blake. Conditions apply. Your next traffic report in less than 10 minutes, but now here is your forecast. Meteorologist
There it is.
Taylor.
Snow at times heavy, especially for the afternoon. Our guaranteed high 0 to reach about 7 centimeters for Toronto and the west end of the GTA, but 8 to about 15 plus centimeters. North and east GTA, especially for areas that get into some lake effect after the system snow. Guaranteed high today, 0.
So that's a weather report for Toronto. Toronto is about 100 kilometers away from here, a little more than that, on the north shore of Lake Ontario. And the weather there is a little different than the weather here. So they're going to get 7 centimeters. We're going to get 15 here. And if you heard her mention lake effect snow or lake effect streamer snow, that could dump on here where I live. Who knows? We don't know. We're going to see. Gotta hear about the weather because I'm Canadian. Gotta know about the weather. Okay, coffee break time. Then we're gonna do that first alignment step. Finally. So I've just been standing here, kind of listening to the radio and listen to it. Sounds like lightning. There's static crashes. That's a bad sign. There's something going on in this radio. Something is failing, I think. Now, what else could it be? It could be almost anything. Could be the way I have stuff hooked up here.
Could be the band switch. Doesn't seem to be. Could be a tube. It kind of stopped. Something. So when I bang the radio, I make a sound like with my hand right here, and that's covering the sound that's coming out of the speaker. So it is sensitive to vibration. Okay, we'll just have to keep our ears open for it because there's no way I can track it down. Where'd it go anyway? What's this? More traffic? So there's 3 million people live around Toronto, in Toronto, and around it there's another million anyway. So there's a lot of people who use these highways that are being talked about here.
This is causing quite hefty delay. So from basically the 400 and then
Doesn't sound particularly clear either, does it?
The 400, the southbound 400, onto the eastbound 401 in the collectors. So again, it's
Tune it.
getting quite busy within that stretch right now. So basically from the 400 onto here, it's getting quite busy. Westbound 401 delays from west of Bridley to west of Kennedy in the express. Southbound 404 DUP pretty good for the most parts, but again from south of Finch to south of Lawrence.
So I'm listening to the S's in the guy's voice.
Looking fantastic, no delays to speak of, nor is there on the eastbound or westbound side.
So I turned the tone all the way to the high end, and it's cut the bass. Go the other way, kind of the middle. All the way to the bass now.
Some system snow that'll move through and then some lake effects that will take charge with a strong wind tonight out of the west-northwest. Now, system snow...
I don't know. Okay. Small things fascinate me at times. Let's attempt the first step. Now, we got to do this at 21 megahertz. Can you see my frequency here is set to 21. Let me just check here on the so we're looking just to read this carefully. I don't want to get it wrong. 400 ohm, got it in there. 21 megahertz. Oh, shortwave band 4. Okay, so here we go. So it'll be 1, 2, 3, 4. This will be shortwave band 4. Making some sound. Good. And we are going to want to tune this short to 21. Adjust for maximum. Image should be heard when radio is tuned down 900 kilohertz. Adjust. So I'm adjusting this guy here. First one. Okay. And the measurement. And the measurement. Where'd those measurements go? Here they are, all turned sideways. So I want to measure out to 21. So, hey, what happened? The radio just went quiet. What happened there? Volume? So volume drop in the radio. Oh, back up again. Again, this could be anything. This could be how my equipment's connected. Oh, for crying out loud, I don't have the I'm still on the antenna here. Let's come off. Off the antenna. So we'll go on to the signal generator here. There we are. Okay. I thought I said I had a 400 ohm resistor here. I'll make that true. Okay, and an extra capacitor. I expect that to be pretty steady, that sound. It's not very steady, is it?
Okay, carrying on. Okay, first I want to check the calibration on my big machine over here. So I'm way up on the different band. The calibration's way off. Can't quite get there, so we're going to calibrate it at 5. So 5 microvolts times this. So this is 10 times 10, so 5 times 10, 50 microvolts when this is all the way up. That's what's on here. And right now we are looking at why is this way over here? Don't worry about it too much, Jim. Oh, it is. It's the modulation. For some reason, the modulation should work. So I had trouble with this meter. After the unit's been on for like about an hour, this meter starts doing strange things. So we'll assume the calibration is around 30, but we can advance it when we want. Just leave it like that. 21. Okay, so what's the radio really tune? Oh, first we got to tune the radio in close to 21. So the measurement here is, what, I gotta add 2 3/8? No, right from the, yeah, you know, like, oh, this is stupid. They measured it from the index marks, but the index marks don't appear here. So I have to add 2 3/8 inches. Oh my gosh, where's 21? So 21 is right on 6. Oh, that makes the math easy, arithmetic easy. 21 is right on 6 inches, so it would be 7 8 inches, 8 3/8 inches. So I'm now going to set this to 8 3/8 inches. I think this is a better way of doing it than trying to hold that. Well, why I think that, I don't know, but this is what I'm doing. So I had this great big thing here I never get a chance to use. So now I have a chance to use it. So it was 8 3/8. 8 3/8. Okay, 8 3/8. That's from the edge here. 8 3/8. And this isn't particularly handy when I'm doing it. Okay, I'm going to line them up. Short. 8. Yeah, if I do that, that's better. 8 3/8. Yep. So, conceivably, that's now tuned to 21. I don't hear any 21 megahertz coming out of it. So we'll tune the signal generator around, see if we can find where is it actually tuned. So this almost, let's think about this. So this is just off 21. If we come down a megahertz, if you hear it again. Didn't hear it again. Let's go back up. Okay, we go up at 900 kilohertz. We should not hear it. Where did I just go? I lost track where I'm going. 21.7. Didn't hear it again. Okay, I'm going to turn up the signal level here. Still not hearing it. Oh. Okay. Well, that woke the radio up. Huh.
What's that? I just jammed a big signal through it briefly, and the radio woke up.
A lot of strange things happen when you're doing this stuff. So, let's go down. There it is. 19.9, so we add 900. That's 455 twice. 900. It should be 20.8. And I'll turn this down. 20.8. Yeah. Okay.
So that, okay, good. So that shows that it is aligned on the proper thing. It's just not aligned properly. So we will now attempt it. We will attempt the deal here. Look at my camera so washed out there. I don't know. Okay. Don't add more nonsense. Jimmy, come on. Focus, man. Focus. So first we want to figure out which way to turn the tuning. So I'm going to move this up in the direction I want to go and put more juice in it. Now we're going to turn this and find it. I got to look in there. I've got to take a look in there. Somebody show me a flashlight here. Okay. Okay, we're in. We're going to go one way. Do we hear it? Yes, this is the way we want to go. You know, it's really sticky. Oh, I broke it free there. Back. Okay, now it's nice. Still a little jumpy, so we'll go a little past. Okay. We're aiming for 21. Where'd it go? I think we went the wrong way. Okay, let's go up again. Go the other way. Yep. A little bit past. Did we find it? Yep. A little high. So now I'll set this right on 21. This is going to be tricky to do. I can't do it with this plastic tool, that's for sure. There's too much twist occurring in here, and with a sticky adjustment, it will just pop back and forth, pop, pop, pop. And so I want something much more stiff. So I'm going to actually use a metal screwdriver. Oh heavens, what is that? Anybody want to take a guess? This what could have been doing this the whole time. Okay, now we're going back right. Right. Could use a bigger screwdriver and get much more control on this too than this little guy. Why the jumping? Okay, how close are we? Right on the money. This guy's jumpy. These things are jumpy. Jumpy. We're not going to get it any better than that. That's very good. That's very good. Okay. Now I just run away and drink some coffee. I have to go fill my coffee cup because I already drank 1 cup of coffee. So I think I'm just going to leave it like this for now. Drink some coffee and then I'll decide if I want to go a little further with it. We should actually take a look at these instructions before I do that. Take a look at where'd they go?
Where did those instructions go? Here. Here we are. There's that crackling again. Really, that's really not good. Okay, so that's done. The next one is same as step 2, 20.8. Wow, slightly below 21. Why would, I really gotta wonder, like, really 20.8 is somehow different than 21? 20.8, and we do the next one. And then that's the top band done. Adjust for maximum. Listen to it pop up and down. Boy, oh boy. There is something going on in this radio for sure. Okay. 20.8. So now here's the difficulty here. How do I know like I've got no dial in front of me. 20.8. How am I supposed to know it's there? Do we just get off this 21 and go down a bit? And then just match the signal generator to it? Why not 21? How can this possibly be important? Because I'd like to do it right where it is now, because I know where it is. I got no idea why they would specify a slightly different frequency. So on that basis, I'm going to leave it where it is, because I'm going to enjoy my stupidity. I'm going to leave it where it is, and I'm going to make that adjustment, and we'll just see what happens anyway. It's the aerial adjustment. Oh, it's way back here in hole number 3. Aerial adjustment in hole number 3. Now the thing is, we don't have a real antenna on here, and I think you really want to do these adjustments with the actual antenna you're using in the end, not something in the shop here, basically a 400 ohm resistor. But we will do it. We will do it. So it was third hole over. Just double checking, because I have a way of getting this wrong. You don't want to get it wrong. Oh, 1, 2, third hole over. Okay. And we're just trying to max this meter, but you can't even see it. I might just bring it up here. That's a little better. There we are. All steady and stable. Not terribly. I need to look in the hole here. Excuse the back of my head. There's no excuse for the back of my head. We're going to start with this on the basis that maybe this one's nice and smooth. Okay. Stuck. Wow, very sharp. This is not what I thought it was. This can't be an antenna adjustment. This sharp. Look what I've done here. I shouldn't have touched it. There we go. Yeah, leave that alone. Holy smokes. That's incredibly sharp. Usually the antenna adjustments are, maybe it's because I'm up at the high frequency. Listen to this radio go. Let's do this. We will end the alignment process. We'll switch back to the antenna. We'll see what this thing picks up on this top band here, which, by the way, wouldn't expect too much at this time of day, but you just never know. Is everybody happy here? Is there a short circuit happening over here? No. We're okay. So I'm not touching anything. Listen to it. Certainly sounds like a breakdown type situation. Okay, so we're going all the way here to start. Now we're coming back. It's about here where the string comes off, by the way. Anybody? Any signal? Oh.
bringing God's people back to His original plan for their lives. The message you will hear today was taught at our local church by Brother Verdi son-in-law. We pray you will be greatly blessed by this message. Now here's Pastor Malin Mulewood.
Oh boy, I tell you. Okay. Well, you can see it's working quite well. I picked that up nicely.
Apparently that can happen.
So if you look at the history of radio, when radio broadcasting first started up, what were they going to broadcast? So they broadcasted some music, and that it had to be live. There was no recordings. I guess there were recordings. Sure, there must have been records. But a lot of it was done live. Guess who caught on to the whole idea? Churches. And churches became among the very first consistent programming material to go out on radio. And here we are 100 years later. They never stopped. What is that? Don't know. What would that be? Gone now. Moving on. What happened with it? It's over here now. So either radio's jumping around, or that weird thing we just heard. Like hard to tune when it's jumpy like this.
Son of John, love me. He said to him, yes, Lord, you know that I love you. He said to him, shepherd my sheep.
It's pretty good reception.
It's passed in the U.S. Senate.
Will enable the Ukrainian people to defend themselves against Russia's ongoing brutal and unprovoked attacks. It will provide Israel with what it needs to protect its people against Hamas.
So are you familiar with chaos theory? Anybody? Have you ever read up on it? It's a theory that was developed when I was in college. Uh-oh. They have more trouble on this capacitor. I didn't notice that before. So chaos theory. So chaos theory says systems that appear chaotic actually aren't completely chaotic. There is a chaotic pattern. And I'm going to show it to you, because that's what I believe we are actually experiencing in the world right now. That it's just mathematics. It's nothing to do with anybody or any politics. It's mathematics. So a chaotic system might look like this, right? Oh, you can't see it. Come on, man. There's just too much light in this world. Let's just kill that one. You know what? That light's going to come right back on again as long as I'm in here. Great. Okay. Well, it won't come on again. The radio quieted down. So, chaotic system, right? Doing this thing, you can't really predict it. Chaotic systems continue to be chaotic until they tend to fall into, and I'm sorry you can't see this again, they tend to fall into what would look like a somewhat stable pattern. And they will exist in this somewhat stable pattern for some length of time. And then they start going out again. And they go out, and who knows what they're doing, and eventually they fall into another sort of semi-stable pattern for a period of time. You see this right now, what I'm doing? That's the world since the Second World War.
been pretty stable. There's been forces to stabilize it. Thank you, United States, for stabilizing the world. The United States not so interested anymore. Lots of things happening. And try as they may, even if the United States wants to stabilize the world, eventually chaos takes over. Chaos takes over for some length of time until something else will stabilize it, more or less. That's our world right there. There it is. That's what we're living in. This chaos idea applies to all kinds of things that appear chaotic, cannot be predicted, and but still have some kind of a pattern to them, which can be analyzed mathematically to some degree. Okay, so it's been fortunate to listen to this radio at length this morning. Start to hear some of the things that are kind of undetectable, so that was putting a little noise in there. I never finished tuning. What happened? I started talking or something?
And I welcome you today to CSC Talk Radio. It is my honor, my privilege, and my pleasure to be here with you today. We're going to go straight to the Lord prayer and get right to it here. For such a time as this, oh, most gracious Heavenly Father.
For such a time as this, you hear a lot of this kind of talk that, although I just showed you the the chaos and the fact that we're in a chaotic period right now, worldwide. Yeah, I have no point. Oh yeah, I already went down to do this. Okay, we're going to start with the capacitor tomorrow. Try to sort out why it's still doing this, and then carry on with the alignment. But so far we got the IF aligned, we've got the top band aligned and working well. Progress is being made. So thanks a lot for watching, and you enjoy your day. I'll be waiting for a blizzard to come in a few hours. See ya.